morning all of you, and let's try a beautiful question on integration. The question goes like 0 to 1 x square mod sine n pi x dx. Let's call this in. We need to find limit n tends to infinity I of n. Now this question can be asked in advance in many forms. For example, they can ask you to relate I5, I6, I7, or possibly they can directly ask the value of I5 or I4. Okay, so I am taking the more general version of this. Before we go further, let's understand the question. Suppose if we have I5, so it means 0 to 1 x square mod sine 5 pi x dx. Now we know this mod value will break at the point when the inside stuff is 0. So let's make sine 5 pi x equals 0. So that gives 5 pi x equals n pi, where n is integer. I'll take positive integer because our limit of integration is from 0 to 1. So that gives me the value of x equals n by 5. It means now I know the breakage point for positive integer. The breakage point is going to be 0, 1 by 5, 2 by 5, 3 by 5, 4 by 5 and 5 by 5, which is 1. So we have 0, 1 by 5, 4 by 5. Now what we can do is we can investigate the nature of the function in this interval. So as you can clearly see, when x is from 0 to 1 by 5, 5 pi x will go from 0 to pi, and in 0 to pi the sign nature is positive, so sign is going to be positive. In pi to 2 pi it's negative, and so on and so forth it repeats. So here we'll have positive, again in next interval negative, positive, negative, positive. So this is on alternate basis we'll get the sign scheme. It means the breakage point for the integral will be 0 to 1 by 5. It will open as same. So I can write it 0 to 1 by 5 x square sine 5 pi x dx plus 1 by 5 to 2 by 5 x square, and that will open as minus sine 5 pi x dx. Again we'll have plus, minus, plus, and so on and so forth. So this is the fundamental meaning of the question, which now definitely we can integrate, like all these expressions term by term. Now there is a quick way of integrating this. Suppose we have integral x square sine 5 pi x. We don't need to do it every time. We can use integration by parts, or we can use repeated integration by parts, generalized integration by parts. For instance, if it is a to b, this one, I can leave x square and integrate the other part. So sine ka integration will be minus cos 5 pi x by 5 pi, and minus I can differentiate first and integrate second. So minus 2x, integration of that will become minus sine 5 pi x by, that's 5 pi, so it's 25 pi square. Again plus I can differentiate first and I can integrate this remaining, so that differentiation will give 0, and integration of sine is again minus cos 5 pi x, and that's going to be 125 pi cube, and now differentiation of 2 will be 0, and so on. So this will be the integral, and now we can evaluate this expression from a to b, a to b. So this is how I am going to use integration by parts in this problem to give the generalized description. So I hope now once you have understood the feel of the problem, it's not very difficult to conclude from here. Instead of breaking from 0 to 1 by 5, 2 by 5 when n equals 5, we can now break in a generalized way. So for a general n, we'll have breakage point 0 to 1 by n, 1 by n to 2 by n, 2 by n to 3 by n, dot n minus 1 by n, and last will be 1. And again in the first interval, integral will be positive, the mod will open as negative, positive, negative, positive, and so on and so forth. So that depends on the value of n. Okay, so keeping this in view, now I can write the given integral as I can break up in different intervals. So I can write this as sigma k equals 0 to n minus 1. You can just decode by breaking it. Integral k by n. So at any point, let's say if you are taking 1 by n to 2 by n, so k by n to k plus 1 by n x square mod sine n pi x dx. And this by integration by parts. This entire quantity can be integrated in now. But here we have a very smart way of dealing with this, because I know the mod will open as positive and negative, that depends on the value of interval. Okay, so this can be done in a very nice way, because we can write x square sine n pi and x minus k by n. So x minus k by n. Now from here you can see, if I'll keep the value of k 0, we'll get definitely first interval as positive. If I'll take the value of k as 1, so that gives me x square sine n pi x minus 1 by n. So that will evaluate to x square sine n pi x and minus pi, in which you can clearly see sine theta minus pi is going to be minus sine of pi minus theta, so which is minus n. So automatically it will open depending upon the value of k. So this smartness of mod of sine n pi x can be written in a very smart and in a smart manner in this fashion. It will take care of all the intervals, whether to open it positive or negative. Right? So with this now, it's just rituals. So we can open using integration by parts. And if we'll do so, as discussed previously, so we are going to get the value of 2k square plus 2k plus 1 divided by n cube pi minus 4 by n cube pi cube. Just use integration by parts twice, or you can use a generalized integration by parts as I have mentioned. So this is the value I am getting for in. Now we need the value of in at n equals infinity. So basically we have to use summation sigma k equals 0 to n minus 1. So in will be sigma k equals 0 to n minus 1, because this is just the result of integration by parts. अब we already know sigma k square is going to be n into n plus 1 into 2n plus 1 by 6, and sigma k 1 to k summation is n into n plus 1 by 2. So with these two information, and remember we have to take k 0 to n minus 1. So I'll replace n with n minus 1. So this quantity will become n minus 1 times n into 2n minus 1. Similarly, this is going to give you n minus 1 times n by 2. This by 6, right? So plugging this value over here, now I can distribute is like 2 times 2 by n cube pi sigma k square plus sigma k and plus 1 by n cube pi. How many times? We have n minus 1 times. Right, so 1 by n cube pi n minus 1 times. And again we have minus 4 by n cube pi cube n minus 1 times. In fact, k is going from 0 to n minus 1, so that will become n times, right? Similarly, it is n times. Now plugging all these values over here, the calculation that I made will give you 2 by 3 pi plus 1 by 3 n square pi minus 4 by n square pi. Okay, so this is the value of in that we got. Now let's say if question is about I5, then simply you put n equals 5, we'll get the answer for this, right? Similarly, I can find I4 and we can relate this using this relation. But interestingly, limit n tends to infinity will simply kill this, because 1 by infinity ending 0, this will get kicked away, and the value of eigen when n is very large is 2 by 3 pi. Hence the answer to this problem is 2 by 3 pi. So I hope you have understood and enjoyed, and it was based on the basic idea of integration by parts, but how we can use smartly. Okay. You might feel question is lengthy little bit, But the point was, the takeaway from the question was how to break the interval and use a smartness in doing so. Okay, so these kind of questions can be asked in advance. There are many problems in integration which is really challenging, but I'm not giving that because let's give content which is useful for the examination and effective also, rather than just efficient problems. Okay, because there are many sources even on YouTube where they give questions, but out of the context questions are available. Let's say if I mix up a vector problem with integral equation, it is of no use because you have never seen in the last 30 years JEE Advanced is going to mix unrelated topic. What they'll do is their mixture is also essential, right? ऐसा नहीं जो कुछ करके भी कैसे भी cosmetically you create a question. तो जैसे प्रोबेबिलिटी में इफ़ आई हैव टू मिक्स लेट्स से कैलकुलस, उसमें भी देयर शुड बी अ वेरी जेंटल एंड स्मूथ मिक्सचर ऑफ द प्रॉब्लम्स. फॉर एग्जांपल सपोज ऐसा आपसे पूछा जा सकता है कि लेट्स से आई हैव अ डाइस, ओके, स्टैंडर्ड डाइस लाइक शोइंग 1 to 6 and dice is thrown and the result on the dice thrown, let's say thrice, is n1 n2 and n3. So what is the chance like a given cubic equation will have a real root, or what's the chance like the given cubic equation will have maybe natural solutions? For example, suppose, and this is already there in my book, so the question is this: suppose you throw a dice thrice in succession, so d1, d2 event and d3, or you throw 3 dice at once. So of course the outcome on this dice sample space is 1 2 3 4 5 6. So the question is, now consider a cubic equation x cube minus n1x plus minus 1 times n2 times n3 equal to 0. So this is the cubic equation. Now first question is, what is the probability that this cubic will have 3 distinct real root? Distinct real root, where what is n1, n2, n3? They are the numbers that is shown on the dice d1, d2 or d3, or the numbers which is shown in succession in 3 through. For example, n1, n2 and n3 belongs to this set and they are randomly chosen. The second question is, what is the probability that this cubic will have natural solution? Natural solution. Natural solution is natural solution is the solutions which is positive integers like 1 2 3 4 like this. Okay, so these two questions is again interesting and you can give a try for these two. The answers that we will get, let me tell you the answer. For the first one, answer will come as 7 by 18, and for the second one it will come as 5 by 36. And that's not very difficult. Like you see how beautifully the question is created. Okay, by combining calculus with like the basic idea, probability or permutation and combination. अब यहाँ पे how calculus is there, so as a hint I'll just give you the basic idea. Let's say you have cubic x cube minus some alpha x and plus beta equals 0. Anyway, it is in this format because alpha and beta is going to be constant. Now if it has got 3 distinct real root, so we know like for cubic, the possibilities of cubic to give distinct real root will be this, because x at infinity it has to go to infinity, at minus infinity minus infinity. तो अगर cubic ऐसे cut कर रहा है, then we'll get 3 distinct real root. अच्छा, but it can also like make its derivative 0 twice, still having a single real root, like this cubic can do, or even cubic can do like this as well. Okay, so how I'll get to know it has 3 distinct real roots? That's easy, because we can take this as an expression. Let's say f, if I'll differentiate, we have 3x square minus alpha, derivative is 0 at the value of x equals plus minus root alpha by 3. Now I know at the value, let's say this is x equals root alpha by 3 minus root, and this is x equals plus root alpha by 3. Now the necessary and sufficient condition will be at the critical point, the point where derivative is 0, must give the opposite output. So let's say at the sign here, if it must be positive, then this guy should be negative. Right. Here since already it's going to infinity and minus infinity, so at a lower value, it must give, positive value and upper value it must give negative value. So what I can tell is, if I'll plug this, let's say this entire quantity, if I tell x1 and this quantity I'm telling x2, so if I'll plug x1 cube minus alpha x1 plus beta into x2 cube minus alpha x2 plus beta, so this product must be negative. So if this product is negative, it will necessarily capture this filling, because here you see product will be positive and here we have product as again positive. So that negative is automatically capturing this. Now again you might tell like sir, here it will capture product negative is plus or minus or minus or plus, but here of course this is automatically rejected, minus and plus, because for the lower value you must have positive answer. अब इसमें if you put the value of x1, so x1 is minus root alpha by 3 और फिर इसको put करोगे, so you'll get a relation, okay, because it's also not very difficult to see, like we have a square minus b square form. This x1 cube if I'll keep, तो आपका जो वैल्यू आ रहा है वो क्या आ रहा है, माइनस रूट अल्फा बाई 3 होल क्यूब, so minus times alpha into, so that will become plus alpha root alpha by 3 plus beta. Another quantity is root alpha by 3 whole cube minus alpha times root alpha by 3 and plus beta. So this product should be less than 0, right? And now we can see some striking similarity over here, because I can write it as a plus b into a minus b. कैसे? As you can see, if beta is already common and we have this quantity is negative of each other, right? So if I'll take beta plus alpha root alpha by 3 minus alpha by 3 whole cube into beta minus alpha root alpha by 3 and minus root alpha by 3 whole cube, ऐसे करके we can write, right? And this would be less than 0. And now it's no wonder, like we can see it's a plus b into a minus b kind of a structure. So this will give beta a square minus इसका whole square. तो इसका whole square में alpha into alpha by beta. You can of course simplify this more easily also. This is just one of the way I'm doing. And minus root alpha by 3 whole cube इसका whole square. अब इसको if you'll calculate, so things will get settled and you'll get a relation like some 27 b square is 9 alpha cube or something like this. Okay, so that you can just check once. So actually you'll get something a square is less than 4 by 27 alpha cube. I think beta square you'll get as 4 by 27 alpha cube. Just when you'll expand this. So now once you know beta and alpha, you already know what is beta and alpha in terms of n. So now we can do case making and find the solution. Okay, so based on basic calculus, see how question can be asked and it can be connected nicely without being forcefully connecting it. Okay, so I hope you are enjoying the lecture, and please do like and subscribe so that I can come with more quality content for you. Thank you.